Hello, Keith Rucker here at VintageMachinery.org. Guys, today we're back to working on our lead attachment for the K&T horizontal milling machine, which we're at right now. The lead attachment is back here on the back. This is for cutting spiral gears, which I've got a job coming up that I need to do that. And I've been kind of trying to piece together some of the missing parts from this lead attachment box that I found. And two of the things that we need to do is to make a couple of spur gears. These would be change gears that go into the lead attachment to adjust different leads. Now, I have been successfully able to find existing gears, change gears for this. I've got a complete set except for two. I'm missing a 20-tooth and a 24-tooth change gear. And in a previous video, what I was able to do is I took some of the larger gears, change gears for this machine that were extra to me. I turned them down to the correct size because they have a special spline in the center here that I really didn't want to have to make unless I just had to. So I just cut down some larger gears that were extras, and today's job is going to be cutting the teeth in these. So these spur gears are a 10 diametral pitch. We've measured that, we've confirmed that. Again, one of them is a 20-tooth, one of them is a 24-tooth, and we're going to be setting up the milling machine and the dividing head to cut those gear teeth today. Let's get in here and get at it. So in cutting gears, the first thing you need to do is figure out what diametral pitch the gear is. And when I say diametral pitch, basically we're talking about the size of the gear tooth. This is in Machinery's handbook, which is a must-have manual. If you don't have a copy of it, it has everything you need to know about cutting spur gears in it, including all the formulas to do all the math that's required that you're going to need to calculate out. But it shows in here the different pitches, just an illustration. Of course, there are actually many more pitches than this, but as the pitch number increases, basically the size of the teeth decreases. And again, these are 10 pitch that I've got, and you know, you can actually take these into the book, and these are at full size, but really the neat way to do it, or the easy way to do it, is to find yourself a pitch gauge. This is a gear pitch gauge set. This one here is made by Boston Gear Company, Gear Works, and it has a sample of each size pitch. And of course, there's your 10 pitch. We put those together, and we can easily tell what pitch we got. This is basically my go-to tool. These little sets are kind of expensive if you buy a new one. Even finding used ones can be expensive, but it's really a nice accessory to have around the shop. So I know this is a 10 pitch, and again, this is one of the other change gears that we have that we're going to be using, but that's how I checked my gear pitch. The next thing you need to know is what cutter to use. So, you know, there's these involute cutters that have the profile to cut that slot just like such. And for each pitch, there are 8 different possible cutters, and they're numbered. This is a number 6, 10 pitch number 6, and basically the cutter number you pick depends on the number of teeth that you're cutting. And the reason for that is as the number of teeth increases and decreases, the geometry of this little area that we have to remove changes on a gear. Ideally, you would use a tool like a hob or a gear shaper, which would make the perfect what they call involute shape, which is this curved shape for whatever gear pitch that you're cutting. But if you're cutting them on the horizontal mill, like I said, there's a set of 8 cutters, and you use a cutter for a range of numbers of teeth. As far as which number cutter you need, again, you can look that up in the Machinery's handbook. There's a table in here, and there's your 8 different cutters, and it tells you what range of numbers of teeth you need for each gear cutter. So the number 1 is for doing the really high numbers, so 135 teeth to a rack. A rack is just a flat gear that basically you can roll across. 55 to 134 teeth, you use a number 2. And for example, I've got 2 different gears I'm going to be cutting. One is a 20 tooth, one's a 24 tooth. So for the 20 tooth, we got 17 to 20 teeth. We use a number 6 cutter. For the 24 tooth, we use a 21 to 25, which is a number 5 cutter. I've got those 2 cutters. Again, there's my number 6 10 pitch. We'll use that to cut a 20 tooth gear. So let's set up our arbor over here on the horizontal milling machine. I've already got an arbor in here. This is just from the last job that I did. I haven't even taken it out. So we will go ahead and pull our old cutter out that we're going to swap out here. Let's get that out of there. So we're going to go ahead and put our cutter on here. First thing I want to do is look at the directions. So I want this arbor turning in a counterclockwise direction so that the teeth are cutting toward the dividing head. I want it to be pushing the work into the dividing head. So I make sure I got the cutter on there in the correct direction. There is a key right here that slides up on that will turn that gear. We'll put some spacers back in here. We'll put our bearing back on, and I'm just going to kind of finger tight this right now. We'll tighten that up once we get the overarm support in place. Now on this horizontal mill, I'm going to run my overarm supports out, and we're going to put the arbor support onto the overarm supports. And we'll go ahead and tighten that down. Now this arbor support basically will support that arbor on the end, so it's supported on 2 ends. Just gives it a lot more rigidity. I'll pull that up onto the bearing there, and we will lock our overarms into place. We got a couple of screws up here on the top. Tighten these up, and those will just clamp this overarm so it doesn't move around. Our arbor is supported nicely now, and last thing I want to do here is go ahead and tighten this up. Don't forget to do this. And the reason I wait to tighten this up, I always say this in my videos, but I always try to tighten and loosen this nut with the overarm or with the arbor support in place. If you don't, you're putting a lot of torque on this. You got a lot of leverage sticking out of there. You can bend an arbor really easily. So I always tighten and loosen that with the bearing support in place. Next, I'm going to put our gear in here. I've got this on a little support. This has got that spline on one end. This is actually a piece that I made for the lead attachment that will hold a gear on this end. That's exactly what this end is for, and I'm just using that as an arbor to support this while I'm working on the dividing head here. So I'm going to put this into my chuck, and I'm putting it all the way back in there. I got plenty of room, and that way as the cutter cuts into this, it's putting pressure pushing into the dividing head. So I've actually got it hitting all the way in the back of the chuck, so there's no room for it to slip or move. And we will slide our foot stock up here on the end. This just gives some more support, and we'll go ahead and tighten that up in place with some wrenches here. Purpose of the foot stock is just to give some support out here. Again, it cuts down on any flex as that's cutting, so this really can't bend down because it's supported on both ends. We've got a nice solid mount there holding it in place, and the next step here is going to be to center the cutter up onto the work. All right, to center this gear up, I'm going to do a little cheat hack here, whatever you want to call it. I'm not going to do any great measuring or anything like that. We're just going to use the cutter to kind of eyeball the center here. So I've got you lined up. Now, I'm just going to say right up front, I may not have you lined up perfectly down the center of this, so it may look like it's off one or the other when I do this, but I can see here what's going on. And it actually looks like I need to bring the table in just to touch, just eyeballing it. But I'm going to slowly bring the table up. Let me bring it back just a little bit. Try to get that cutter right in the center. All right, I think that's about right. And I'm just going to slowly bring my table up until that cutter is just barely kissing the blank up underneath it. You guys may not be able to see this as good as I can. In fact, let me move the camera around over here a little bit different angle. All right, I'm just going to slowly bring that up until it just barely touches the top. And yeah, I'm just barely hitting it right there. I can hear it. There's just a tiny mark there. I'm going to come up just a little bit more. All right. Now what I'm going to do is I'm going to bring my table in a little bit. Hopefully you can see that mark in there. What I'm going to do now is I'm going to bring the table in and out across that, and it makes a mark. And because I just moved the table in and out, it's going to make a mark all the way across and basically where it's intersecting there. I'm going to bring it up just a few more thou. Hopefully you can see that now. I got a wide mark. That right there gives me my indication of where the exact center is. Hopefully you can see that wide mark in there. That gives me the center. And now all I'm going to do is I'm just going to eyeball this thing from the end, and I'm going to line that cutter up exactly down the center of that mark. If you do this really good, you make that mark the same width as the bottom of your cutter. And this is you can do an amazing job of lining one of these things up right on the center. Your eyeball is a lot more accurate than people give it credit for. But we pretty much are right there where we need to be. That's right on center. So I'm going to go ahead and lock the table down, and we're ready to start cutting here in just a minute. Next thing I need to do is figure out how deep my cut needs to be. And I've got a little cheat sheet. This is a little Excel spreadsheet that I put together. And I got the formulas right out of Machinery's Handbook. So these are some of the measurements that I want to have when I'm cutting a gear. I don't really need all of these, but I put them all in here just so that I would have them. But here's the formulas. And the first thing I want to know is how deep does that cut need to be? And right here, hole depth of tooth. This basically tells you how far down we need to make it. 216 thousandths according to the math. And the way you determine that is the formula is 2.157 divided by the pitch, or the 10, which says we're a 10 pitch, so that's going to basically be 0.216 will be what we got here. You know, outside diameter, this is another one. So the number of teeth plus 2 divided by the pitch gives you the outside diameter. So the OD of that gear the gear is 2.2 inches. I cut it that diameter, and now I'm going to make a depth of, like I said, 216. Now, I'm going to do this in 2 passes. And the reason is that I'm going to make the first pass be a roughing pass, and we're going to get a more accurate measurement where we measure over pins. We'll put a gauge pin directly across from one another here. We'll measure across that. I've got, again, what those measurements should be, the pin diameter that we need to use, and we'll measure over those wires, and that's going to give us our final adjustment. So we're going to basically make the first cut, we'll measure over the pins and see how much more we need to cut to get to the proper depth of cut. This is just kind of a rough guide right here. So I think what I'm going to do is we're going to do about 175 thou which will get us most of the way, and then we'll come back around the second time and make the final cut. You know, if I was doing a production job, once I get it set to the proper depth of cut, I have no problem with cutting the full depth of cut in one pass on a horizontal mill machine. It will easily make that cut. The reason I'm doing it in 2 passes is more so that I can hit that number dead on. I don't want to just dial this in and accidentally cut a little bit too deep. So we're just going to do it in 2 passes. Now to measure that depth of cut, what I've got is I just put a dial indicator on here, and we're going to raise the table up, again, 175 thou. So one full circle on there is 100 thousandths, so we'll make one full circle and then dial in 75 more right there. I'll lock my table down, and this first pass isn't super critical. We're just going to make a cut, but that should give me about what is that, about 30-40 thousandths more in that final cut to clean out of there to get to the proper depth. So as far as figuring out which plate we need to put in the dividing head to get our number of teeth, we're cutting 20 teeth on this gear, and this dividing head is a 40-to-1 ratio. So the math is really pretty simple on this one. It's half of 40, so it'll be 2 full turns of the handle. We can use any plate, any hole to index this on, and we'd make 2 turns, 1, 2. When I do that, it's turning the dividing head. Again, it's 40-to-1 ratio, so to turn this chuck 1 full revolution, I turn this handle 40 times. To get 20 increments, I do 2 full turns per operation. We are ready to go. Let's make our first cut here. So I've looked up in my speed and feed charts, and for the speed of my cutter, it's a 2 3/4 inch cutter. We're cutting in steel. I want to be cutting at about 100 surface feet per minute. So that's going to be the speed on this diameter. And to get there, it says around 130, 140 RPMs. Closest one I got is 124. So that's what we got our speed set to. Right now I got my feed set to 4.5 inches per minute, which we can probably cut faster than that, but I tend to go kind of conservative. So let's go. I'm going to give some cutting oil in here, and we'll make our first cut, see what it sounds like. Cutting like butter. All right, we're through cutting, back up, and we'll make our first turn of the dividing head. 1 turn, 2 turns, we're ready to go. Put a little cutting oil in there. Here we go around the world. I like the way it's cutting. We could probably cut faster on our feed rate, but I'm not in a hurry. This is a production job. We'd probably play around with it and get a maximum feed rate, but again, I'm in no hurry. Let's make our next division. And that's what we're looking for. We're going to split that final two there, cut that tooth right out. And that'll be the last pass for this round. When we come out of here, we're going to pull it out. We'll make a measurement across those pins, check the diameter, see how much we need to adjust to make our final cut, and one more round and we'll have it. So now from some inspection work here, what we're going to do is we're going to measure across a couple of pins. So we're going to use a specific size pin here. And again, all the math, all that, you can figure all this up out of Machinery's handbook. But for a 10 diametral pitch, you need to use a pin diameter of 0.168 inches. I have two of those, and I'm going to put them across from one another. I'm then going to come in here with a micrometer, and we will measure across those pins and figure out what that is. So let me get a good measurement here. That feels good right there. All right, so we are measuring 2 inches, 296 thousandths right there. Now my measurement should be 2 inches, 222 thousandths. So I'm going to do some math here. I'm going to subtract the 222 from the 296, so minus 0.222. So that tells me that I need to go a total of 74 more thousandths. But you got to remember, we're going to take half off of one side and half off of the other. So we divide that 74 thousandths by 2. I need to move my table up 37 thousandths, which is very close to what we had kind of figured from the beginning. And I'm just going to dial that in with a dial indicator. We'll make another pass around here, and we should be right on the numbers. So let me move up the table. We'll make an adjustment and make a little light pass and get this gear into tolerance. Got my dial indicator in here. Again, 37 thousandths is what we need to raise up. I'm going to loosen my table lock, and up we come. Let's see. That's 10, 20, 30, 5, 6, 7 right there. Lock the table down. There we go. Should be right on the money. I'm going to make another round, and we'll double check those measurements again across the pins. Not taking much out this pass compared to the last one. But it's just what we need. And that is it. We are through. All right, let's check across our pins again. And guys, I'm going to do full disclosure here. After I went around the last pass that I recorded, I hit my number I was shooting for, but then I looked back at my sheet and I was going to the wrong number. I was supposed to be at 210 instead of 222. I had two measurements and I was looking at the wrong one. Let's see where we are now. So we are at just a shade over 210. So that's 2 inches, 210 thou, which is right where I wanted to be, or where I needed to be. And like I said, and the difference is I have two measurements on my worksheet. One of them is the actual measurement over the pins for a perfect tight fitting, and then you have a backlash allowance where you want to have a little bit of backlash in that gear. And to do that, you need to go a little bit deeper. And with the backlash allowance, I needed to go to 2 inch, 210. rather than to 222. So anyway, that was a little difference there. I just made another adjustment, had to make another cut all the way around. We did that off camera, but we are right where we need to be. All right, this gear is done. I need to cut my 24 tooth gear. I'm going to do that one off camera. Exact same process. We'll just have a little bit different dividing measurements on it, or dividing segments on the dividing head, but same process. We'll bring you back when we're done. Well, there you go. We got our 20 tooth gear all finished up here, and turned out nice. I'm happy with the results. Turns out I didn't get the 24 tooth done yet. I just ran out of time today and didn't get a chance to get back out here to the shop to finish it up. We'll finish that up another day, and I'll probably just do that one off camera. Exact same process we just did. But one down, one to go, and I'll have a full set of change gears. Happy to have this getting closer and closer to being done. And with that, that is going to be a wrap, guys. We're all finished up on here. Always a joy to get to use my K&T horizontal milling machine, one of my favorite machines in my shop. I've said it before. I think the horizontal milling machine is an often overlooked machine as far as its usefulness and what you can do for it. Maybe not in today's CNC world. They're really overlooked, but traditionally these things have been great production machines, and great, even I find in a job shop situation. I wouldn't want to be without one, and they're great for cutting these gears on. So with that, that will be a wrap. As always, thanks for watching, guys. Please subscribe to the channel if you haven't already. Thumbs up and comments are appreciated, and we'll catch you on the next video. Thanks for watching.